Welcome to Festive Tech Calendar 2025. I'm happy to be here. Unfortunately, I cannot show myself because I have problems with my computer. But in any case, trust me, I'm sitting here smiling, and I hope we will have a lot of fun in next 30 minutes or so. Today, I will present you a talk named Advanced MCP for .NET, and it comes from my real experience working with .NET and MCP technology model context protocol. We will cover MCP registry, security, and agent orchestrations, and how we can use MCP there. Before we go, let me introduce myself. My name is Oleksiy. I'm a lead software engineer at EPAM. Also, I work as AI coach. I do open source and blogging, so you can find my blog here. It's Nikiforov All blog. Please feel reach out if you have any questions, and also you can see my open source projects at GitHub. Nice. So before we even start talking about advanced concepts and the MCP, let's see why MCPs are here. First of all, to understand why model context protocol emerged, we need to understand what are the limitations of large language models. First of all, they are non-deterministic. I see LLM as a black box where you have input tokens in and output tokens token out. Also, we have a good will or we expect something meaningful by using all data all over internet or training data sets to impact the behavior of LLM and make it more useful. But the underlying nature of LLMs that they are non-deterministic. Also, they have a cutoff knowledge, and they don't know anything about the external environment, the current date, what the latest JavaScript framework, and so on. Also, they don't have an ability to interact with external world, and interaction can only be simulated through function calling. And also, they have a security and privacy concerns because LLM behavior can be impacted through prompt injection. So it's good idea to have a man in the middle in the form some sort of MCP server controlling what's can be done with external systems or APIs and so on. And just to remind you, MCP is just a protocol to integrate your awesome AI applications with the external world. It can be GitHub, it can be Slack, and so on. And the interesting part about this protocol, it's built on top of well-known ideas such as client and server. On the right, we have MCP servers doing something meaningful, and on the left, we have MCP clients using the MCP servers through model context protocol. And I want to highlight that MCP is not just a wrapper around web API. Actually, it has many interesting features, such as like tools that can provide you an access to data or ability to manipulate external systems. Right? It can access to prompts. It can have elicitations, samplings, and so on. I highly recommend you to delve inside the actual features of MCP, but this talk is not about it, so we will just move on. Um, Hope you sold on this idea that it's awesome to add additional features to AI applications. And to demonstrate you such example, I will use Claude Code and start it with the additional flag called Chrome. After that, we can do something like following. We can ask Claude to browse my blog and to paginate, right? So we can just say browse Nikiforov all dot blog and paginate, and we will switch model to Haiku because we want to be fast. All right, let's see. As you can see, Claude managed to find the attached MCP server, it opened my blog, and now it tries to do some exploratory testing. Let's wait a little bit so Cloud Code can figure out. As you can see, it scroll down. Now it see the older button, and that's it. It successfully managed to paginate. And you can do many interesting automation. Personally, I really like the integration with browser because it opens up a lot of interesting opportunities. Now you don't need to do tedious job yourself. Maybe you can delegate it to Cloud Code or other AI application, right? AI agent or EDE. So I hope you sold the idea on MCPs, and probably you can ask Alexei, where can I find them? And this where the subject of MCP discovery comes into play. Unfortunately, in the prior versions of model context protocol, there were no places official, distributions or websites. They were scattered all around the internet, so you kind of need to just use Google search to find them, and it has significant problem. There is no single source of truth, no standardization, and no trust model. This is where MCP Registry comes into play. It's basically an app store for MCP servers, and it has nice additions to it that can help you to use it in your own organizations. So basically, what it solves discovery because you can now find available MCP servers across the ecosystem and across trusted resources. It solves the problem of trust and validation by using GitHub OAuth. And also, it provides you a way to make everything discoverable. And there is additional namespace management to prevent conflicts. And the idea of this protocol to accelerate system growth and to address, of course, well-known problems such as poor discoverability and fragmentation. And if you take a look at simple interaction between MCP clients such as VS Code and MCP servers and registry, basically at some point of time, developer publishes MCP server to a registry, and now MCP client can connect to MCP server and kind of discover them from MCP registry. And actually, VS Code has awesome support for MCP servers and the registry. It's called GitHub MCP registry. You can just type MCP, and it will show you MCPs available to be installed directly from a known MCP marketplace. So you can just type, for example, browser, and you can find they suggest Playwright to use browser automation, and also you can type Chrome, and there is also MCP for performance profiling and integration with the browser, from Google. So many interesting options, and as you can see, this is really natural for me to just discover an MCP server. Okay, let's move on and see a broader picture of MCP registry. Actually, it's quite composable. So in this case, you can define your own MCP registry for your own companies that you're working on. You can reference other registries, such as like official MCP registry or from GitHub. And MCP registry can contain a lot of different MCP servers that can run by Python, Node, Docker, and also with .NET. Recently in .NET 10, DNX was introduced, so you can run .NET tools as through the MCP registry and this standardized process. All right, and actually MCP protocol is very simple, and the idea is just to have a place to define definitions of MCP servers. And if we come back to the terminal, we can just run the query to MCP registry from model context protocol here. And as you can see, it defines just the MCP server that has a transport type of std.io, meaning it should be run locally. It defines the registry type. OCI is for containers, And also it defines external, variables that should be provided in order for this MCP registry to work. Another example this time is the remote MCP. It's what's Alpic test MCP server. Not sure what it is, but as you can see now it has a streamable HTTP. Streamable HTTP means that this MCP server are not locally installed. MCP client is not responsible for running it. It's running somewhere in the internet on the internet. And if you take a look at the publishing process of MCP server, there is already ecosystem around it. We have a CLI tool called MCP Publisher, and basically you edit your a server JSON and publish it using your GitHub identity. Here the example how you can define MCP server for .NET application. You provide the name of the MCP server on NuGet, and also you provide the registry type NuGet, right? And the transport. So in this case, you can use Nugget to distribute your MCP servers in .NET ecosystem and run them through DNX without even bothering to install .NET Global tool. Okay, awesome. We covered how you can distribute MCP servers and how they can be very useful. But what about user identity and authentication? This is really important topic if you want to build MCPs in production, if you want to truly deliver something meaningful, because usually when there is data, you can play with it and do something interesting for user. Not just to do something local. And this is where MCP servers with support for OAuth 2.1 comes into play. Basically, security should be 0-day implemented, and you definitely want to care about, basic security principles. And since MCP servers acts as a bridge between AI agent and data sources, or between EDEs and so on, it's good idea to think about how you can prevent security breaches, because security breaches can compromise sensitive data. Maybe malicious actor can manipulate your AI application behavior, or it can lead to unauthorized access. So it's good idea to follow best security principles such as defense in depth, think about multiple layers, follow least privilege principle, and implement proper logging and monitoring for your setup. For authentication concern and authorization, I have template prepared. So everything you need to do is to run this CLI command to install it, and you will have something like this: HTTP server auth. And as a result, you can create MCP server by running .NET New, the name of the template, and provide some defaults. The output will look something like this. And the interesting part here, we have Echo tool that uses user server that will have user identity locked from from the authorization server. Before we run a demo, let's see the structure of program CS. Basically, it's built on top of well-known building blocks. We have here application builder. Also, we add access to HTTP context by using HTTP context successor, and we define the additional secret sauce to the authentication scheme. It's a new challenge scheme intended for MCP servers. It's called MCP authentication defaults authentication scheme. And now we also need to provide special protected resource metadata. Basically, it's a special resource that defines for MCP clients where to find authorization servers so they authenticate user against them, right? And also we add a mapping to API to support well-known MCP endpoint, and we authorize it, right? And let's see how we can use the identity. In this case, I'm injecting in my MCP tool defined based on primitives from MCP SDK, official SDK from Microsoft, and I'm injecting here a user service that we can use to get a username. And as a result, we can provide a message and we will be prompted with hello message from and the username of the currently logged user. Awesome. Before we start the application, we need to configure it. On top, we have a configuration for Microsoft Entra authorization server, and down below we have MCP server URL to be a part of protected resource endpoint. And now we can just run application. One way is to work with it from MCP inspector, but the better way is to use VS Code and MCP JSON config. Now we can do something like following. We can open MCP JSON. As you can see, I already have my AI application running. We will clear current dialog. We will restart it so we can connect to MCP server. As you can see, it discovered one tool, and now we can connect and use the tools from MCP from VS Code to just mentioning, for example, Echo tool and say something like hello tech calendar 2025 and let's see how it goes. I already authenticated, so we will not see the whole dance of redirects, and you don't bother me uh, logging into the system and so on. But as a result, okay, let's see. Organizing tool calls. What is it? Preparing tool calls. It's taking a lot of time. Okay, finally it came up with this input, and as you can see, it asks me to run my Echa MCP server tool with the uh, button to allow it. Let's allow. It's called my Echo tool, and as you can see, hello tech calendar 2025 from Alexei and my identity. Awesome. And as you already noticed, this is not just to get a username. This is basically a user identity that you can use to implement role-based access control, maybe some resource-based authorization, and so on. Since you have a user, it opens up a lot of interesting opportunities. Awesome. And I will not go into details of how the authentication works under the hood, but it's good to know the overall flow that is used. So once the AI client is ready to make a call, it makes an unauthenticated request to MCP server. After that, MCP server responds with the 401 unauthorized, right? Or authenticated. Once the client knows that server is not authenticated or rejects the request, it can use the special header to retrieve protected resource metadata. And basically, header is provided by a server. As you can see, we have localhost 5000 running. This is the remote MCP server, and there is a well-known auth protected resource endpoint. Actually, it's the same as endpoint from my slide, but I have a little bit of different port. But in any case, this is how it's got injected, and here is the way to configure it, right? Protected resource metadata. So let's jump back to the browser. As you can see, it provides a authorization server URL. So the client, which is VS Code in this case, can authenticate. Okay, simple as that. And if we skip to the most interesting part, to the diagram, we have the same as I described, but in more helpful way. First is to we authenticate, then we are presented with VV authenticate header that contains protected resource metadata. Then clients tries to receive it, and the authorizations flow is started between client and authorization server. You see, MCP server is not involved in this case. It's authorization server. And once the flow and the dance of redirects is finished, you can have a user, or not a user, rather client, can have a valid GVT that it can provide, and the MCP server uses this GVT to authenticate a user as a regular web API would do. So the flow is highly composable. It's built on top of well-known primitives and standards such as OAuth 2.1. And yeah, you can use it with the ASP.NET Core applications to use same identity system and reuse it throughout. Awesome. Personally, I'm really big fan of how authentication is implemented. You definitely don't want to use API keys in every case, and you don't want to implement authentication yourself. Spare yourself from sleepless nights. Let it be, implemented by guys who are professionals and know their craft, right? On to the next one, MCP in agentic system. I will demonstrate you how to use MCP in conjunction with two popular options in .NET community. First one is Microsoft Agent Framework and another one is Azure AI Foundry. Microsoft Agent Framework is a cloud platform implementation written in .NET and Python, supported in .NET and Python. I mean, that has a unified abstraction for AI agent. Basically, you can integrate with multiple backends, aka LLMs, such as Azure OpenAI, AI Foundry, Olama, or you name it. Also, it has built-in features such as function calling, multi-turn conversation, structured output, and streaming. Also, it has interesting functionality such as workflows. It allows you to orchestrate agents into very interesting workflows and scenarios to support agentic systems. Basically, Microsoft Agent Framework is a combination of semantic kernel and autogen. Another building block is Azure AI Foundry. Basically, it's a unified platform for building, evaluating, and deploying AI agents. In today's demo, I will demonstrate server-side persistent agents with built-in MCP support. I like Azure AI Foundry because it's enterprise ready and it supports everything you need in production: authentication, monitoring, compliance, and scalability. In today's demo, I demonstrate how to build an agent to query Microsoft Learn to ask questions to overcome the um, limitation of LLM of cutoff date. So you can actually get the recent information in your AI application and system. So as you can see, first we need to define agent. Here I'm defining persistent agent with the connection to Azure AI Foundry endpoint. Next, I need to define an MCP tool. As you can see here, I use remote MCP server connected to well-known endpoint provided by Microsoft Learn guys. Then I'm defining persistent agent that consists of four parts. First is model. Basically, it's a LLM, and it's a LLM name or endpoints that should be used uh, for this run or for this agent. Second one is the name of the agent, just as an identifier and for convenience. Third one is the instructions, aka system prompt. System prompt defines overall behavior of an agent and helps you to orchestrate provided tools. Tools can be different tools. In this case, I have only one MCP tool, but for your applications you could imagine having hundreds of tools responsible for different parts of the system, and it can be something more complex. This is just to demonstrate a basic approach. Once you define your agent, now you can use a client to create a thread. Once thread is created, you can dispatch a message by using create user message. Once the message is created, you can actually create a run. Run is like a session for your agent, and you need to specify a thread an agent and the tool resources scoped to this run. Once the run is scheduled, you can inspect the results or intermediate status of the run by using get run async. And in reality, it's created in status queued and moved to in status in progress uh, when it's processed, and moved to status completed when the processing is done. And next, you can use get messages to process the messages after the run is completed. In reality, you can mix and match these calls to implement a streaming like behavior, but in my case, I just have a simple CLI agent that you can run inside the terminal. So let's see how it works in practice. I will run it. In this case, it's one file that describes the whole agent. I use newly introduced feature called .NET Run Files. As you can see, I'm providing packages without CS Proj. I'm consuming Azure AI Foundry endpoint using my managed identity, configuring agent, and providing a remote MCP, creating a message, unwrapping the results and waiting for completion in the spinner using Spectra console, and presenting results as when this run is completed. So let's see. I started an agent. Now agent is syncing, making some requests to remote MCP from Microsoft. And as you can see, it responded with nice summary of actual documentations that it found by using MCP. And despite this demo being simple, I think it demonstrates an interesting approach how you can build your AI systems by decomposing them into agents and providing them MCP tools to communicate with external world. There are many interesting aspects of building AI systems, but for today, I think we are equipped with essentials, such as how to distribute and package your MCP servers, how to implement security, and integrate them into AI agentic systems. Thank you for participating in this uh, event. I appreciate your time, guys, and I see you soon. Have a nice day.